Hello and welcome to the first video of the first units. So here I am on Desmos, which is an online graphing calculator, and the goals of this video is we're going to be learning how to transform functions, scale them up, or make them go down, or make them go left or right. So let's start off. So I'm going to start off by just graphing the base quadratic function here, y is equal to x squared. And that we can point out some key points. We have a point 0, 0, which is known as a vertex. We have the point 2, 4, which is pretty identifiable right there, 2, 4. And we also have negative 2, 4. So what I want to try to do is I want to see if I can just transform the graph up 1 unit. So now the first thing that comes into my mind is the way we can achieve this is why don't we just add 1 to the entire function? So that's what I'm going to try to do here. So I'm going to just add a 1 to the x squared. So notice if I add 1 here, our vertex goes from 0, 0 to 0, 1. So it just increases the y value by 1. And if we also look, normally our point would be at 2, 4, but now let's see where it ends up. It is at 2, 5. So notice how the 4 increased to a 5. So we just scaled our function up 1 unit. Now I could try to increase it even more. Let's say I wanted to add 2 to the function. And notice, this is pretty clear. Our original quadratic went from 0, 0 to 0, 2 now because we added 2 to our function. So basically, in general, if you add something to a function, it will scale the function up. So you basically are going up. So now what if we try to go into the negatives here? So why don't we just try to subtract something? Say subtract 1. So notice I subtracted 1 from the function, and now I'm going 1 down 1 unit. So initially I was at 0, 0, now I'm at 0, negative 1. So all this does is, if you either add or subtract, it either transforms your function up some units or it goes down some units, depending on what this number is. So we can actually generalize this here. So let's say we have x squared plus k here. Let me add a slider for k. So if you start at k is equal to 0, we notice it's just our quadratic because we're not really doing anything to it. It's still a quadratic. So it's still our base quadratic. So notice it's just the exact same, 0, 0. We have 2, 4. But let's say if you wanted to set k as 3, for example, we should expect our vertex to be at 0, 3 because all we did was we added 3 to our y value. So there we go. There we have it. And also our 0.24 should now be at 2, 7 because, right, we're adding 3 to our y value. So let's double check that. And there we go. It is at 2, 7. And the same thing could be for negative numbers as well. We're subtracting in this case now. It would transform to 0, negative 3. And this would go to, normally a 0.24 would go to now 2, 1. So yeah, there we go. So now that we know how to actually make functions go up or down, how about we make functions go left or right? So in order to do this, I think we have to adjust some values inside the x. So if I go inside and make brackets like this, and let's say I wanted to subtract 1 from x, what do you think will happen here? So if I do subtract 1, do you think the function will go left 1 unit or it'll go right 1 unit? So if I plug it in, it actually goes right 1 unit. So notice how if I did x minus 1, it just transforms the entire quadratic right 1 unit. So normally our vertex would be at 0, 0. Now it's at 1, 0. So basically shifted the entire quadratic 1 unit to the right. So if we wanted to, say, add 1 to function, inside the x, you'd probably expect it to be a complete opposite. We'd want to go left 1 unit, so right? So now that we're at negative 1, 0, we'd normally be at 0, 0. So depending on this, whatever's inside this, if you're adding or subtracting, you either go left or right, which I have a Google Slides which shows this more clearly. But let's say we wanted to subtract 3. So now we're going 3 to the right, because we're subtracting in this case. We're subtracting 3. So we just go 3 units to the right. And a way to think about this is initially we had an x value which we're squaring 0, right? So now in order to square 0 again, what x value do we need to have? Well, 3. We need to keep this value to 3. In order to keep whatever is inside this bracket 0, x needs to be 3. So right, if it's 3, then we're squaring 0, which is just 0. So that's a way to think about it. But yeah, so we can even add a slider for x here. Let's just say this is h. And let's say we start at 0. We haven't done anything yet. But if we subtract, let's say 5, we'll go 5 units to the right. But if we subtract 4, we're only going 4. So this applies for every single point on the quadratic, by the way, not just the vertex. And we can even go to the negative, so you can do negative 3, transform to negative 3, and there we go. So let's get on to some of our notes here. So vertical translations. So the function y is equal to f of x plus k, where k is the vertical translation, k units up or down. So right, we just learned that. So k is basically what it adjusts our function up or down. And for horizontal translations, it's y is equal to f of x minus h. Notice how the h is right beside the x. It's inside the brackets. So basically, if h is positive, then it is a horizontal translation 8 units to the right. So if we're subtracting a positive h here, then we're going right h units. Same thing for this here, similar case. If we're adding h, and if h is positive, then it's a horizontal translation h units to the left. So we're going h units to the left if we're adding something here. And there we go.